For centuries, humanity has gazed up at the night sky, at the countless stars scattered across the darkness, and wondered, how far away are they? The universe was a beautiful but profound mystery. We saw galaxies, stars, and nebulae all floating in a vast, dark ocean, but we had no way to measure the distances between them. Our cosmic map was completely flat. We had no sense of scale, no depth, no idea of the true size of everything. The universe was a two-dimensional painting. Then quietly, a woman working in near silence changed everything. Her name was Henrietta Leavitt, and she would give us the ruler we needed to measure the heavens. At the turn of the 20th century, the world of astronomy was a man's world. Henrietta worked at the Harvard Observatory, but not as an astronomer. She was a computer, a title given to women who were hired to perform tedious, repetitive calculations. They were paid far less than their male counterparts and were strictly forbidden from even touching the powerful telescopes. Henrietta's world was a small, quiet room. Her job was to examine photographic plates of the stars, glass slides covered in tiny black dots, captured by observatories from all over the world. Day after day, year after year, she meticulously catalogued and measured the brightness of these stars. And in this painstaking work, she began to notice something peculiar, something no one else had seen. She was focused on a special class of stars known as Cepheid variables. These stars weren't constant. They pulsed. They would grow brighter, then dimmer, then brighter again, with a perfect, clockwork-like regularity. As she compared thousands of these pulsing stars, a pattern emerged from the data. A simple, elegant, yet revolutionary rule. Henrietta discovered that the brighter a Cepheid star truly was, the longer its pulsation period. A faint Cepheid would pulse quickly, maybe over a few days, but a brilliantly luminous Cepheid would take weeks or even months to complete a single cycle. It was a direct, predictable relationship. This was Leavitt's law, and this discovery meant something absolutely extraordinary. Think about it. If you could see a Cepheid variable star anywhere in the universe and measure how long it takes to pulse, you could use Henrietta's law to figure out its true intrinsic brightness. Then, by comparing that true brightness to how dim it appears from Earth, you could calculate its distance. It's like knowing a 100-watt light bulb will always be the same brightness. If you see one that looks dim, you know it's just really, really far away. For the very first time in human history, we could measure the cosmos. The universe suddenly snapped into 3 dimensions. It had depth. It had scale. Henrietta Leavitt had handed us the cosmic yardstick. But her groundbreaking discovery wasn't met with awards or grand celebrations. In fact, it was barely acknowledged. Male astronomers, her own superiors, took her formula and ran with it. They began measuring distances to faraway star clusters and nebulae. Most famously, an astronomer named Edwin Hubble used Leavitt's law to study the Andromeda Nebula. He found Cepheid variables within it and calculated its distance. The number was staggering. It proved that Andromeda wasn't a gas cloud inside our own galaxy, but a completely separate galaxy, millions of light years away. The universe wasn't just the Milky Way. It was filled with countless other galaxies. And by measuring their distances and speeds, Hubble used her work to prove that the entire universe was expanding. Hubble became a household name. His name was given to the world's most famous space telescope. The universe became infinitely bigger in our minds. And Henrietta Leavitt, the woman who made it all possible, remained almost completely invisible, a footnote in someone else's paper. She died of cancer in 1921, at just 53 years old. She passed away without ever knowing the true, universe-altering impact of her discovery. Years later, a Swedish mathematician nominated her for the Nobel Prize, not knowing she had already died. The prize is not awarded posthumously. It took decades for the scientific community to fully admit the truth. Without Henrietta Leavitt and her meticulous work in that small, quiet room, modern cosmology as we know it would simply not exist. She didn't discover a new planet or name a galaxy. She gave humanity something far more fundamental, far more profound. She gave the universe a ruler, and history almost forgot her. Thanks for watching. If you enjoyed this story, don't forget to like and subscribe for more tales from the hidden corners of history.